Welcome to the presentation entitled Modeling with Time Series Data, including a demo of integrating Aerospike with Grafana to review that time series data in real time. My name is Reuven Kaswin. I've been with Aerospike for 4 years. I am located in the New York metropolitan area, more specifically in New Jersey. What we're going to do in this presentation is discuss some approaches towards modeling time series data in Aerospike, along with the details and a demo for one specific sample approach to the modeling of the time series data. What we're going to do is cover lists and maps in general, differences and similarities between the two. We'll discuss the storing of time series data in lists and maps, why you choose one over the other. We'll introduce some sample code which stores time series data in lists, and we will show an integration with Grafana to review that stored time series data in real-time graphs. We'll also cover adaptive maps, which is a pattern, a design pattern geared towards storing maps of virtually unlimited size. What are the similarities and differences between lists and maps? Well, some simple obvious differences are that maps are composed of key value pairs, while lists are collections of values. The key value pairs must have unique keys in a map. That's a major hindrance in time series data. We'll talk about that a little later. The similarities between the two are that both may be composed of either simple data types, integer, float, and float being stored in doubles in Aerospike, strings, and blobs. They also may be other lists and maps, so you may want to generate a hierarchy of lists and maps, and we'll talk about that in the next slide. Lists and maps may be ordered or unordered, depending on what suits your need. And they support basic functionality, such as getting the size of a list or a map, retrieving entries of a list or map by index, by rank, and again, I mentioned previously, they may be ordered or unordered. Very important item here are the storage efficiencies for lists and maps. MessagePack, which is a industry standard storage format, is used to store lists and maps within the Aerospike records. It can provide a huge savings in terms of storage space, and storage space on SSD is still not free. There's a link, of course, here to the spec and the documentation on MessagePack. There's also a link here towards an Aerospike knowledge base article covering the differences between storing data in bins and storing data in maps in terms of the disk usage. Both these links are available, obviously, when you download the PDF file for this presentation. A couple of approaches here, some simple examples for storing time series data. We can use the list as containers, in this case a list of lists, where each member of the sublist, in this example, is a timestamp followed by a value. In the case of a stock ticker example, it's a time and then the value of that stock, or the price of the last trade of that stock, should I say, at that timestamp value. Another approach is to use maps as containers for time series data. The important item is that maps must have unique keys. If you cannot be assured that you will be receiving unique keys, you cannot use maps. Very simple. In this example, we have a timestamp as a unique key, and then the value for that key value pair is actually a list. And that list is composed of two members. One is a basic data type, which is a string, followed by another map. We're showing some of the hierarchy that you can use lists and maps for. What should you use at the top level? Should it be a list or a map? Well, if you have a unique key value, then obviously either one could be used. When in doubt, I would use a map if I have a unique key value. And the question is it possible to receive multiple records with that same timestamp value, them not being unique. In that case, obviously, you can't use the map. Another question to ask if storing a timestamp is, what's the base value? The standard approach for a timestamp value is relative to the epoch, which is a date in 1970. Message pack are very efficient in storing integers, and the smaller the integer, the smaller the number the smaller the data in integer, the less data stored in message pack. It's not taking up a full 64 bits, irrespective of the integer size, which is a basic integer value. So if you can get that timestamp value to be smaller, you can save significant space on your SSD. Think about changing the epoch for your timestamps. Another question is, do you really need to store timestamp values at all? Are you receiving records at a defined interval? In that case, you may not need timestamp values. You can store an interval counter, or just assume an interval if you were receiving records at a defined interval, where, for example, if you want to keep a running series of the last X data points, let's assume X being 100, what you can do is, and if you're getting that data, 1 record per second, you know the last 100 data points represent 100 seconds. I don't need to store that data. I just need to know the relative offset of that entry in my list. So think about what you're storing. When you're talking about storing large sequences of data, then you want to look for the most efficiencies you can in terms of storing data. One of the most important issues is you want to avoid downloading and uploading large records. That causes major issues in terms of your network latency, throughput, and bandwidth. You want to limit as much activity you can on a record, as many updates as you can to the server itself. The goal is to stay on the server when possible, and we'll talk about something further down to make life easier for you in that case. The maximum record size has increased a couple of years ago to 8 megabytes from 1 megabyte, and a beginner approach is to say, oh, Aerospike supports 8 megabytes as a maximum record size. We'll just make our maximum record size 8 megabytes, and we won't worry about it, unless our record's obviously larger than 8 megabytes. That's not a good approach. That's a beginner approach. We strongly recommend against that. We recommend picking optimal record sizes. Now, obviously, if I need that much data and I'm going to have multiple operations on records within that data, within that record, or should I say, if I need to execute a transaction against a large record, then I need a large record size. Aerospike does not yet support multi-record transactions, so if you need to support a transaction in a large record, then that's what you need. No ifs, ands, and buts there. The real overhead there for large records is in terms of defragmentation. There's a defragmentation process running in the background for Aerospike, and it's manipulating. When you use larger records, it has larger records to manipulate, larger records to read, larger records to write, and it causes overhead in terms of more activity in terms of I/O on your SSDs. So this overhead, this background overhead, providing more activity on your SSDs is taking away from available SSD throughput that could be used for your normal read, write, and other operations on your records. So it does produce a load. Again, this background process now, you have an administrative process that's taking resources away, more resources away from your mainline real-time processing. Obviously, the SSD space issue I discussed previously, message pack being used for maps and lists, is a great approach that we use towards limiting the SSD space required. Talking about some solutions to avoiding downloading and uploading large records. The Operation API functionality, we'll talk about that in the next slide. That allows you to make multiple changes to a record, to read change, make other, I'm going to overload the term operation, execute multiple operations on a record within a single API call and have all those take place on the server. So again, we'll talk about that further on the next slide. Another possibility is to use a capped map or list. A capped map or list means that you've set a limit, and at the same time, once you hit the limit, at the same time you add an item to the map or list, you prune an item from the map or list to keep it at that cap. You can use the operation API functionality to perform both within the same API call, all on the server. For non-maps and lists, compression, which is an option that we provide now, can save significant space in storage. If your maps and lists may expand to more than 8 megabytes, if you're not sure, then you have to address them. One approach is to use pseudo keys. If I can define my maximum size, my maximum number of records that I need to support the entire map or list when I've split it out, then I can create pseudo keys. One simple approach is to augment the true primary key with a suffix derived from the entries of the map and list. Another approach we'll discuss at the end is the adaptive map. That will support essentially unlimited maps up to and including the limit of your namespace. So you can have one record with a map that takes up your entire namespace. Again, that's not necessarily what you want to do, but that is the hard limit on that for obvious reasons. Some of the extensive functionality, and we keep adding to this functionality in our releases. We've got much more functionality than we had just a few releases ago, and again, we're constantly adding. One thing that was added relatively recently, last year, was the ability to do operations down towards various levels of nesting of a list and map. We previously only were able to execute operations at the top level. So again, very valuable that you can actually go down to multiple levels and execute multiple operations. For example, I may retrieve a record from a list or map, add a record to a list or map, increment a member of a list or map, and remove a member of a list or map, all of them within one API call and one transaction. Again, the operation functionality is overlooked by many people. Take a look at it. Even if you're not storing time series data, think about what you can do to minimize the movement of data down to your client. Let's do things on the server as much as possible. Next, let's cover an example. This example, a complete example here, I'll only show some of the code, but the full example is defined in a couple of blog posts, which are the same blog post posted twice in two different places. And what we're going to do is show what we do to populate historical tick data. We'll simulate simulate the addition of real-time tick data, and also we'll view that tick data via a Grafana graphical interface. What is our use case here? Well, in the real world, the stock ticker data rise at a very high rate for thousands of securities, and that data needs to be stored in real time. You can't fall behind. You want to be storing that data in real time and query that in real time. What we need to store is obviously the time and the price for that for the last trade for that individual stock symbol. A huge load on a database, but again, not a problem to store it if you've properly sized your Aerospike cluster. What are we doing to store the data? We in this approach, this demo, I'm violating what I said earlier in terms of picking a smaller value for the epoch based on a more recent epoch, but this is just a demo here. Because we can receive multiple tick records for the same millisecond, I cannot use maps. Maps are immediately eliminated because I know I cannot get records with the exact same. I can get records, with the exact same millisecond, which means I can't use an approach of using the timestamp as a primary key. If you were getting some sort of unique identifier, obviously that could be used as the primary key. So the record key that we're storing is the stock symbol concatenated with date. So what we're going to store is a large list of lists per stock symbol per date. That's going to be our basic storage for the detailed data for each stock symbol. So each stock symbol concatenated with date is a primary key, and the list of lists of all the trades for the day, all the values for the day, is stored underneath that. We'll also, looking at the use case, you have to think about what you can do for efficiency's sake. If I want to retrieve a record in a graph, and we'll see this in the demo, of a few months or a few years worth of data, why do I need to retrieve from Aerospike records for let's assume you're doing a year. Why do I need to retrieve a few hundred records and all the ticker data for a few hundred records just to produce a simple graph which doesn't require that granularity? It's a complete waste of resources. Let's save those resources for more valuable needs. So what I chose for this demo was also to store a single record per symbol per year with the daily closing prices. So this is creating this record here that we'll store for a year is great for the low granularity queries. The record key is a stock symbol concatenated with the year. This is greatly minimizing my I/O and network traffic for low granularity queries. Again, I'm taking making the storage, the structures that I'm using, match my use case. I'm not driving the use case from my storage. I'm driving the storage design from my use case. For baseline data population, we use Yahoo Finance, which provides us with free historical price data. I downloaded 5 years for a few symbols. Excuse me. For a few symbols, I downloaded this data, which includes for each date the opening price, the high value for the day, the low value for the day, the closed value, the last value of the day, and an adjusted close. Sometimes there's an adjustment. I shouldn't say sometimes. There's often an adjustment at the end of the day, and also the volume. What I do is create a vector or an array, if you want to think about it that way, of tick data that I generate for each second throughout each day based on the range of between the high and the low values that were provided to me. So we create them in a vector or an array, if you want to look at it that way, and we use OneOperate API call to append all those items to my list in my record for that day. So the symbol and the date is the key, and then all of the items, all of the data points are stored in the list. Also, what we did for populating real-time stock data, and I put the word real-time in quotes. If you've taken any computer science classes, you know real-time has a specific meaning in computer science, so I need to put it in quotes. For us pedestrians, real-time is different than computer science real-time. But you set up I set up a CSV file with symbols, with stock symbols and high and low values and a maximum percentage change. In this case, it's telling me generate data for IBM between $130 and $145, but don't have one tick be different from the other by more than 20%. I don't want to generate wild swings in my graph. I'm trying to make them look more realistic. And again, for every second, and this program is going to be running full-time during the demo. It's actually running as we speak. It will generate data, a new entry every second in this case, for each stock symbol. Basically, sleep for a second, wake up, produce data, and store it into the Aerospike database. Now, to store the data point, we're not bringing the entire record down with potentially a large list and then adding an entry and sending the entire record back up to the server. We're using the list operation here, and that, as described earlier, take advantage of operations. List operation to append to my data points, append a single list value, which is composed of the ticker, of the timestamp and the value, the price of that stock. Add that one entry to that list. So this operation gets sent to the server. Within the server, the record is read, the append is made to the list, and the record is written. The client does not have to retrieve the record at all. The record does not show up at the client site to make this happen. What's next is, well, we have to develop a Grafana data source. The first step in the Grafana data source is to connect, is a basic connection to the Aerospike database. This Grafana data source is based on an example in the Grafana download, which uses Python and Flask. And next, this is the guts of the code of the data source. The guts of the data source is composed of building an array of keys of what records I want to retrieve from Aerospike to populate the screen for Grafana. As I said earlier, if I'm looking for a small number of days, in this case less than 3 days, well, let me just retrieve the daily closing prices. Excuse me, if it's, I take that back, I apologize. If it's less than 3 days, I want to get the detailed data, the detailed tick data for those 2 days, for less than 3 days. Those 2 days, I want to get the full detailed tick data down to the millisecond, because that's what someone wants to see on their screen. If it's greater than or equal to 3 days, just give me the daily closing price for every day. Don't waste my time with doing that. So, again, I populate based on the number of days or years. I populate the array, which represents the number of the records that I want to read. And I make one API call. The batch API call is a very valuable API call in Aerospike. It literally fans out, because the data is split among your cluster. It fans out all of those requests to your appropriate nodes in your cluster, and there's a lot of parallelism taking place here. Very important. You don't want to do, when you can, you want to do batch reads as opposed to a series of individual record reads. It makes a huge difference in your latency of your applications.
Now let's look at the demo in real time. I've got a screen here, a browser screen that is connected to a Grafana server. That Grafana server is connected to an Aerospike database. In the background, I also have a program generating real-time data into the Aerospike database. Let's start by looking at the historical data that I loaded. Let's pick IBM here and look at 5 years worth of data for IBM. This is real closing data for 5 years. As you can see at the tail end here in early 2020, most of us are painfully aware, that's when IBM, as well as many other stocks, took a big dive. I can drill in anywhere I want to in this section. Let me drill in. Let me go down to first. Let's go down to looking at 1 year's worth of data. And then let me drill into a small section, that 1 year worth of data. And drilling to that small section, I see multiple days worth of data. Now, why do I see only large ranges of the data in a small section? Well, New York Stock Exchange and most other exchanges in the United States trade from 9:30 a.m. to 4 p.m., and that's where you see the variation. So if I drill in here, you see variation within a day from 11:05 a.m., it looks like, till about 12:35 p.m. And this is data that I generated, and it's being extracted from the time series data stored in the Aerospike database by Grafana using the connector that I built for the demo. Let's move on and look at some real-time data here. Let's go to look at the last 5 minutes worth of data. And I can set up Grafana to refresh every 5 seconds. And so every 5 seconds, we're going to refresh the IBM ticker price. And you see the data every 5 seconds being updated on the right side. If I could refresh more often, I could refresh every second, we'd see a change. I guess I can do that by running the query whenever I want to, at least every second. And I can just click the button every second and make that happen, or by default every 5 seconds. And let's add to that by adding another ticker symbol. I will add Walmart here, another well-known brand. And every 5 seconds, we are doing a refresh of them. And again, I can do them more often. And as I'm populating every second, I can see a refresh of data on every second, and I'm constantly viewing that. Again, this is a real live running demo with, as I said, with Grafana, pulling data out of Aerospike, which is populated by a Java program that is generating dummy data. Okay.
So what are the issues here with time series data? It was all simplified before with the stock example and what I discussed earlier. In reality, you might get a great variability if you're storing records on a per date basis. Then you might have, in this case, a credit card data. You might have a single credit card due, and for most people, most credit cards, less than 20 transactions per day. And so that works out fine. But what if you've got some outliers? You may have outliers. In fact, there are businesses that will under one credit card number or one account, will have 100,000 plus transactions per day. In that case, you end up having potentially a large object size. And what do we do here? You don't want to size the block size to cover every possible number of transactions, any possible record size here. What you want to do is pick a reasonable size that has some outliers there, so that in most cases your data will fit into a single Aerospike record. Your entire time series data fits to a single record. This can't always be the case. You may need to go beyond that. But the point is, you want to try to pick a reasonable block size that will support the greatest number of use cases. If you get beyond that, then what do we have to do to address these limits? Address the record size limit, the 8 megabyte limit. If we picked 8 megabytes here as the right block size, but we know there are going to be some records that are beyond that, or we know that we need to handle that. So obviously, if you know what the frequency and size of data you're going to see, then you'd pick buckets which will enable the optimal record size. So again, if you know the data, you pick the size that you need, and maybe you want to do regular sampling intervals, not save every millisecond in some cases if it's an IoT type approach, not save the time series data for every single millisecond, but maybe every second. So decide what you need to save, pick buckets which will enable the optimal record size, and then obviously you may need to deal with outliers based on that. If you have irregular sampling intervals that you need to save, for example, the credit card transaction we discussed earlier, where you need to save everything, you can determine the mean arrival rate, and then you pick, again, buckets where the majority fit inside the record size and deal with the exceptions. Those outliers will cause, obviously, issues for the object size. So what do we do to address all that? We have this design pattern called an adaptive map that was derived by our clients, their services group, and it's used by multiple customers. So we manage this record overflow in a software layer. We use lists of maps, obviously, as I discussed earlier, for powerful operations within records. Very important if you want to get the details. I'm only going to be skimming this approach. But for full details, I recommend you go to the GitHub page that covers this, and it covers it in extreme detail, and it will be much more valuable at that level. Again, I'm just trying to skim that. What happens in this adaptive map is it relies on logically splitting records when adding time series data. So when records get full, we split records, and we have an approach to provide a hierarchical tree here to retrieve data. So based on your key, we are taking, in this case, bits of a digest generated from the map or list entries. So you take the timestamp, for example, you do something, you route based on the last digit, and then the second level down, you map on the second from the last digit. So again, without getting too deep in here, the point is this approach, which, as I said, I provided a link to, will support unlimited size lists and maps. Unlimited size lists and maps. Limited, of course, by the size of your namespace and any of those approaches there. Again, very important. If you need to support unlimited, look at this. One thing important here is, even though it seems relatively simple here, it's conceptually very simple, but in reality, this is more complex than even what I'm showing here, because you need to manage items such as locking and dealing with logical transaction semantics, because you're updating potentially multiple records in Aerospike at the same time. So there's some logic that's required that's non-trivial to support this, but if this is an important use case that you must cover, this is the way to go. This concludes the presentation. This is the way to go. This concludes the presentation. Hi there. So ready to do handle some questions now that have been passed along. The presentation. And I don't know where that beeping is coming from. Hi there. So ready to do handle some questions now. Okay. Hopefully I'm being heard now. Let me cover a few questions that I've seen here on the list. And number one that I was asked was, what's the optimal record size for performance? Well, that's an interesting question. One of the most important things to do that people ignore often is to run ACT testing, Aerospike certification tool testing, on their either physical or virtual SSDs if you're in the cloud. And the reason that's important is that different devices at different block sizes have different performance levels. So again, an important item for performance is, what does your SSD support? That's normally the major determinant in terms of throughput and latency for an Aerospike application. Important to test a different block size to see what makes sense for you. The default for SSDs is 128K. Obviously, as your record size gets larger, your maximum record size gets larger, you'll be using a larger block size. So number one, make sure you run some ACT testing at the block size and at the read and write ratios you're planning to see in your application. Let's go to number two here of the list that I've got. Number two, I think, is answered here already. Asking about what does the adaptive match approach mean. We covered it in the presentation. I think that was asked before I covered it in the presentation. And so, and there's a link if you download the PDF that will give you the full details, much more detail than I could cover in a short time period. Question about querying. There was a question about, what if you've got composite keys, etc. I didn't mean to discuss every possible approach here. There are multiple approaches, and there are hybrid approaches. So I don't have, without more detail, I can't provide a response to that. But the goal here was to make people understand some of the options available and go from there. So that's one that I can't answer well. And there was a question here about scaling for prices of about 1,000 stocks versus 35,000 stock prices. That's an excellent question. So that's a generic question about Aerospike scalability. And there was a separate question also about that, about how much we can support. I think one of the first questions was, how much can we support in terms of the maximum rate of time series events that we can store? And the good thing about Aerospike is we scale linearly. So we will scale. If you have a certain load that you handle with X number of servers. If you want to double the load that you're handling at the same latency, so double the throughput and the same latency, just about every single case, you can just double the number of servers. So that's a very simple approach. Again, that's one of the values of Aerospike. It's very linear. It's very easy to size a database. There are no, as opposed to other databases where you have a different type of curves other than a straight line out. Very important. There was another question here that was, how much compression should I expect from MessagePack? The link that I provide in the presentation shows a case where you actually have 50% compression, literally 50% reduction by using MessagePack instead of standard bins or lists. So again, that is real money. If you're storing things in maps and lists, that's real money you can save in terms of storage of your device. Many people don't realize that you can just take data that really is in individual bins and put them into maps and lists, and automatically get some savings in terms of space. Let's see if there's any others. I'm not seeing any others here. I think that's basically it. There may be for some more information, more about composite keys. That question came up earlier. Let me pass it on to Tim, who may have some more input on that. Tim, you want to? Tim Fawkes, who's a VP of Technical Services, Solutions Architect, should I say? Go ahead, Tim.
Thanks, Reuven. So the question was about use cases where you have time series data which is a bit more complex and based on composite keys with different possible values. Now, the Aerospike really shines in big use cases where in these typical sort of situations you have a lot of data. The querying patterns you use to get to that data makes a big difference. And we've seen cases where we're doing things like monitoring enterprise applications so that you've got every server is reporting its CPU, its heap map usage, and things like that on a regular basis. That's coming into something like Aerospike, and then the queries are being performed against that. Now, Aerospike is not by nature a time series database, so we don't have inbuilt functions yet for things like averages and aggregates and things like that. So it's very, very good at retrieving the data, even in the ranges, if you use the right sort of data modeling to retrieve ranges and subclasses. We get that data very quickly, and then we can process it in the application code, but not in the database code. So doing the things that you're talking about with this question are quite doable. And there's a number of people who are doing something very similar to that.
Thank you, Tim. There was one more question that came up that I'd like to answer. We have, I think, a couple minutes left. Can a very big adaptive map span across multiple nodes? The answer is, by definition, it will span across multiple nodes because each node in an adaptive map will be a separate record, and each record in Aerospike can be randomly, I shouldn't say randomly, deterministically, will be on a different node potentially based on the hash algorithm that Aerospike uses. So if you have a large adaptive map, by definition, it will span multiple nodes. So that answers that question. I think we've answered all the questions on the list. Thanks everyone for participating. Download, please. Look at the links that are provided and email us with any future questions, and I'll be available and others are available in the other sessions, the Ask Aerospike and the Developer Forum. Make sure you visit there to ask further questions. Thanks everyone for joining, and enjoy the rest of the summit.